Aibon everyone. Today we are going to study very important part, that is about vectors. Actually, without vectors you can't do here onwards other lessons, Newton's laws and projectiles, and after that linear momentum, impulsive forces. To study them, you need this vector principle very clearly. Therefore, it's very important part for advanced level entire syllabus. Therefore, study this one very properly, right? Then first we should know what is the meaning of a vector. Actually, a vector means any physical quantity which has a certain direction and magnitude. Both should be there. Direction and magnitude both. But in scalars, it has only magnitude. For example, velocity, acceleration, displacement, force, they are vectors. But pressure, density, temperature, mass, they are scalars because they have only magnitude. Then if any physical quantity is there with a certain magnitude and direction, it is known as a vector. Then you should know how to represent a vector, right? How to represent a vector. Then to represent vector, we use arrowhead with a certain direction and magnitude, like this. It needs arrowhead and it needs certain magnitude and it needs an angle. Any vector, it can be displacement, it can be force, it can be acceleration, it can be velocity, it can be momentum. Whatever the vector, you can represent by this kind of straight line which has magnitude and direction. Then basically, first we should know what is the meaning of equivalent vector. Then here this vector you can write this point A, this point B, then you can write it here A to B vector, from A to B vector. How do you write that? A to B vector. This means this doesn't imply it is in the rightward direction. That means only A to B. A to B is a vector. With arrowhead you can see it's a vector, right? And you should know equivalent vector. Then you know how to represent a vector with magnitude and direction. And next one you should know equivalent vector. It's very important thing. Equivalent vector means if you can find any second vector, right, which has same direction and same magnitude. For example, if you draw here another straight line, C to D, same magnitude and same direction. These two are equivalent vectors. That means you can equalize them. A to B vector is equal to C to D vector. These are equivalent vectors. You can draw this second vector anywhere. It can be here, here, or in front of this. Whatever the space that you represent the second vector, if both are equal and same direction, you can equalize the same way. Magnitude and direction we can equalize like this. A to B vector is equal to C to D vector. This is equivalent vector. And you should know opposite vector also. That means if you have another vector, right, which has same magnitude but in direction it's opposite. For example, this one. same angle, same magnitude, but in the opposite direction. Then how do you write that? Then you can write A to B vector is equal to C to D vector is equal to minus E to B vector. E to be opposite. Then if you want to change the direction of the arrowhead, you have to apply extra minus sign. That is minus E to F vector. Minus E to F vector. Anytime if you want to change the direction of the arrowhead, you can apply extra minus sign in front of the notation. Then these two vectors are equivalent vectors, this one opposite vector. Now it's very simple notation. Now we are going to study how to add them together, right? If you are given many vectors, you should be able to find resultant of them. That means addition of vectors. Now we are going to study about that. Then it's very simple. If vectors are parallel to each other, you can add them together directly. Straight away you can add. For example, if one vector is here 5 newtons, another vector is here 7 newton. If you want to find resultant of them, very simple, 12 newtons in the same direction. Resultant of parallel vectors. It's very simple. Directly you can add them together. Now, if you are given many vectors, how do you find resultant? Let's see. One vector this way, another vector this way, another vector this direction, again another vector in the opposite direction. Assume this one 3 newtons, this one 2 newtons, right? Other vectors you can take 5 newtons, assume this one 6 newtons. Then how do you add them together? Then easiest way, arrowheads, you have to change the direction of arrowheads in the same direction. After that, add them together. For example, if you want to add them together, right, all the arrowheads should be in the same direction. You know how to change the direction of arrowhead. When it is multiplied by a minus sign, direction of the vector can be inverted. Then same thing you can write here, 3 newtons. Here we want to take arrowheads in the same direction. Then to turn this arrowhead opposite, you have to put here a minus sign. Minus this way 2 newtons. This is the same direction. Therefore, no need to apply extra sign. Directly you can take it as 5 newtons. Again here you can see all the arrowheads you have to take in the same direction. Therefore, we have to add here extra minus sign to change the direction of the arrowhead. Then you can see minus this direction 6 newtons. Then directly you can add them together. 3 newtons plus 5 newtons, you can see 8 newtons this way, and you can see minus 2, minus 6 here, then you can see resultant becomes 0 here. 3 plus 5, 8 upwards, right? Minus 6 and minus 2 opposite, therefore resultant of them 0. Now I am going to increase one more vector here, another vector this way, 8 newtons. Then you can see addition of these vectors was 0 plus that one, resultant will be 8 newtons. Now it is not equal to 0. Now it will be equal to 8 newtons, right? This then parallel vectors can be added directly like this. Now you should know how to subtract vectors, that also. Then same way actually we have to do. I am going to do another example to explain that. Now consider many vectors we are given, one of them here 2 newtons. It doesn't need to be newtons always, it can be meters per square second, meters per second, and momentum, whatever the vector, same manner. Then assume another vector we are given minus this way 2 newtons. Next vector we are given backward direction 3 newtons. Another one we are given in the same direction 6 newtons, and we are given opposite direction again 5 newtons to take subtraction. I told you best method, first we have to change all the arrowheads in the same direction. Then we can see arrowheads, these are in the same way, then no need to change anything. But this one you can see downwards, then you can change that direction by adding extra minus sign. Here also this direction you can change by adding extra minus sign. Then I am going to draw after making them the same direction. Here I can draw 2 newtons. Arrowhead should be in the same direction to add them. Then very easy. Here minus, this way 2 newtons. Then here we have to change the direction of this vector. To change the direction of the vector, we have to add extra minus sign. It's this way 3 newtons. Then here no need to change anything because it is in the same way. Plus 6 newtons in the same direction. And next one you can see arrowhead downwards. All the arrowheads should be the same direction to add them together. Therefore, we have to apply extra minus sign. Therefore, plus 5 this way. Plus 5. Then very easy to simplify them. You can see these two are getting cancelled. Here these two can be added 11. Then 11 minus 3 you can see 8 newtons in the same direction. Therefore, resultant of these vectors, resultant means a single vector which can use instead of all the vectors. If you can find a single vector to represent all of them, it is known as the resultant vector. Then here resultant we can draw how much? 5 plus 6, 11. These two are getting cancelled. 11 minus 3, 8 newtons. That is the resultant. Then very easy to find resultant of parallel vectors. You can add them directly. The next one we are going to do, we are going to find resultant of two inclined vectors perpendicular to each other. You are given two vectors, they are perpendicular to each other. Now we are going to do how to find resultant of two perpendicular vectors, right? Assume one of them, very easy to understand with displacement. Assume this direction, you walk 3 meters. After that you walk perpendicular to that 4 meters. Then we want to find resultant of them. This one 4 meters. Then you know, it is not equal to addition of them directly, right? That is the length of the path. We need resultant of the vectors. Then you know resultant displacement from here to here. This resultant. Instead of these two vectors, you can use this single vector r. Then how do you find that? It's very simple. Pythagoras principle, 3 squared plus 4 squared root is the resultant. Then you can find it 3 squared plus 4 squared, square root of them, it's 5 meters. This is the resultant of these two vectors. Then you should know, if it is true for displacements for any other vector, you have to use same method to find the resultant. Assume 3 newtons this way, 4 newtons this way, then resultant 5 newtons. Then very easy to understand that. Anytime, if you hard to think about that, then use displacement vector. This way displacement 3, this way 4, then resultant is not equal to 7. Resultant is equal to 5. And this is not sufficient. Actually, when you are writing a magnitude of a vector, it's very, very important. You have to write the direction of the vector also. To find the direction of the vector, you can use any angle, this one or this one, both are correct. Now, I am going to use here this vector, this angle theta. For this vector, I am going to take this theta angle. You know, tan theta is equal to opposite over adjacent, right? It's very basic. O level, under O level you did that. Then tan theta is equal to opposite over adjacent. Opposite divided by adjacent, it's 1 point recurring 3. If you use tan table to find that, you will see this angle is 53 degrees. Theta 53 degrees. Then you need magnitude, direction both together, right? Then sometimes this vector can be given in the other way also. For example, assume, now you know, for any two vectors this is true. Assume now you are given another two vector, this direction one vector, it's assume 6 newtons, another vector is given downwards here to here, 8 newtons. Then you can find resultant of them with the same manner. Again, you have to take Pythagoras principle, starting point is here, finally you can see point here, then resultant from here to here, it is equal to same principle, 4 squared, 3 squared root, here 6 squared plus 8 squared root. Then you can see 6 squared we know 36, 8 squared we know 64, square root of them 10 newtons. Whatever the vector, same method if they are perpendicular. And here also we need angle theta. Angle theta, tan theta equals opposite over adjacent. Tan theta equals to opposite over adjacent 8 over 6, again same thing. You can see theta is 53. And sometimes these two vectors are not given like this. Vectors are given in the AL paper sometimes, they starting from the same point. They starting from the same point. For example, I can draw this same vector 3 and 4 again here. Upward direction 4 meters, horizontal direction 3 meters, like this. But same thing you have to do. 3 meters this way, 4 meters this way, you know arrowhead should be this way. Therefore, resultant of those two also same value. Then if you are not sure, you can complete this rectangle here. And you know, according to equivalent vector principle, this 4 you can draw here. After drawing 4 here, again you can't take this here. If you took it once, again you can't draw here 4. Then this 4 you can draw here. After drawing that 4, very easy to think, 3 this way, 4 this way, resultant again 5. Then same answer, resultant same value. Then these two vectors can be given right like this. This 6 newtons can be drawn here, 8 downwards, same thing. Like this you can see, six newtons here, 8 newtons here. Then what is the resultant? Again you have to complete this rectangle, and according to equivalent vector principle, you can draw this 8 here. After drawing 8 here, here to here and here to here, resultant is represented by the same way. Here to here, it's again how much? It should be equal to this 10 again, right? Same thing. Therefore, vectors can be given like this or that, whatever the method. Always, if they are perpendicular vectors, you have to take Pythagoras principle to find the resultant of them. Now, we can do more examples here. Next one I am going to do, we are given two vectors, this direction 10 newtons, this direction we are given 10 root 3 newtons. Then how to find resultant? Again you have to complete this rectangle, you know. If you go this way 10, this way 10 root 3, I told you it is easy to think in displacement. If you walk this way 10 meters, this way 10 root 3 meters, then you can find resultant by this line. Then resultant is equal to this square plus this square root of them, Pythagoras principle, 10 root 3 squared root 3 this squared, and you can see 10 squared square root of whole thing. 10 squared we know 100, and we know root 3 square 3. 100 into 3, 300. 300 plus 100, 400. 400 root, you know, 20 newtons. Resultant of them 20 newtons, and you have to find the direction also. Theta, tan theta equals opposite over adjacent. You know that? Tan theta, now opposite this side. According to equivalent vector principle, you know, this one and this one should be the same. Then opposite over adjacent, 10 root 3 over 10. Tan theta, 10 root 3 over 10, it's root 3, tan theta equals root 3. Then you can see theta is equal to 60 degrees, right? Theta is equal to 60 degrees. This is how we are finding resultant of perpendicular vectors. I am going to do one more example for this. Consider we are given 4 vectors like this. We are going to find resultant of them. One of them we are given 20 newtons, another one we are given 50 newtons, we are given this one 25 root 3 newtons, another one in the opposite direction we are given here 20 root 3 newtons. Then you are going to resultant of them. Then easiest way, first find the vertical resultant. After that, find the horizontal resultant. Finally, you will get two perpendicular vectors. Then again, Pythagoras principle. In the vertical direction, you can see 20 upwards, 15 downwards. Very simple. Resultant of them upwards 5. Then upwards we have one vector, 5 newtons. In the horizontal direction, we have two vectors, 25 root 3 and 20 root 3. It's like 25a, 20a, right? 25a, 20a, it's like that. Therefore, difference of them, it's 5 root 3. Difference of in the horizontal direction, 5 root 3. 25 times root 3, 20 times root 3, then difference 5 times of root 3. Then one vector we have in the horizontal direction, 5 root 3. Now you know how to find resultant of them. They are perpendicular. Pythagoras principle again, you can complete this rectangle. Here to here you can see resultant. Resultant is equal to 5 squared, 5 root 3 squared, square root of whole thing. 5 squared we know 25 and 5 root 3 squared we need square root of whole thing. 5 squared 25, 5 squared 25, root 3 squared 3, then 3 into 25 75, 75 plus 25 100, 100 root 10. And you have to write direction of the resultant also, theta. Tan theta is equal to opposite. Now opposite is 5, adjacent 5 root 3. Then tan theta you can write tan theta you can write opposite over adjacent 5 over 5 root 3. Then you can see 5 is getting cancelled, 1 over root 3, tan theta 1 over root 3. Then theta is equal to 30 degrees. Then if you are given many vectors like this, first find the horizontal resultant, find the vertical resultant until they come to two perpendicular vectors. After that, same principle, Pythagoras principle. Now we are going to study next one, vector resolving principle. It's very, very important. Actually, most important part in this vectors lesson. Vector resolving principle. We know how to find resultant of two vectors. Now we are going to find how to resolve that into two parts. We know if you walk this way 3 meters, this way 5 meters, resultant 5, 3 meters this way, 4 meters this way, resultant 5. Now we are given 5 to find other two components. Now we are going to find horizontal component and vertical component of any inclined vector. Resultant was 10 newtons and angle we found 30 degrees. We know how to find resultant of two vectors. Now we are going to study how to resolve this vector. We are given only one vector. How to find components of them. Components, vector components. That means same vector we can write using two directions, two parts. Those are known as vector components. Then how do you find that? We need only O-level sin theta cos theta principle only. Very simple. If you want to walk this way 5 meters, right? I told you, you can take another two perpendicular paths instead of this one. Now we are going to find those two parts. Those are known as components, vector components, right? Then to find that, we can go from here to here using another two perpendicular paths like this. Now I am going to find how much this one and how much that one. Those are known as vector components of these this vector. Assume this angle 53 degrees. Then you know sin theta is equal to, you know that, sin theta equals to opposite over hypotenuse. I am going to take this as y, vertical one, vertical component. I am going to take this as x. Then you know sin theta is equal to opposite over hypotenuse. Then sin 53 I can write sin 53 equals opposite over hypotenuse. Then cross product 5 into sin 53, 5 into sin 53, right. From the sin table you can find sin 53. You will see sin 53 is 0.8, approximately 0.8. Therefore, here answer 5 into 0.8, it's 4 meters. 4 meters. Then we found vertical component. How much that? Y component we found 4 meters. This is a y component. It is known as y component, vertical component. And this one, you know, cos theta. Cos theta equals, cos 53 equals adjacent over hypotenuse. Then I can write cos 53. Cos 53 equals adjacent over hypotenuse, x over 5. Cos 53 you can find from the sine table. Cos 3 is there. In the opposite you can see. Then cos 53 you will see 0.6, right. 5 into cos 53 equals x. Cos 53 is equal to 0.6. Then x is equal to 3 meters. This is known as horizontal component of the vector. It's 3 meters. But here onwards, we are not going to write these O-level things. Cos theta equals opposite over adjacent over hypotenuse, sin theta equals opposite over hypotenuse. We are not going to write those things in the L paper. Directly you can find x and y. How do you find that? If you want to find opposite vector, opposite, then hypotenuse should be multiplied by sine. Opposite sine, easy to memorize. Then opposite direction directly. Here onwards, we are not going to write cos theta equals this over this, sin theta equals this over this. We are not going to write them, right? Because we are doing now A level. Then y is equal to directly 5 sin 53. You can see y equals 5 sin 53. Here onwards, we are writing them straight away without writing these things. Therefore, y component, vertical component of this main vector, 5 into sin 53, opposite sine. Then you can write 5 into sin 53. 5 into sin 53. In the direction of the angle cos. 5 cos 53. 5 cos 53. Directly you can write that. 5 cos 53. You can see. X component here 5 cos 53. Cos 53. In the direction of the angle cos, opposite sine. Then now I am going to take another two perpendicular vectors, right. Then in the direction of the angle, you know, cos, another one sine, right. 5 meters here, this angle we are given 53. Then you know horizontal component 5 in the direction of the angle I told you cos, vertical one sine. Here onwards you should learn to write it at the same point. 5 cos 53 here, 5 sin 53 here. Same thing you are going to write about the same point, not like a triangle, like this. This is equal to two components, y component, x component. How do you find them? 5 opposite we know, opposite sine. 5 sin 53. Then this one you can write 5 sin 53. Same way. And 5 cos 53. This one. Like this. You should learn that also. It's very, very important. Then any vector you can resolve in the horizon with the arrowhead. With the arrowhead. Horizontally, if this angle theta, in the direction of the angle cos, another one sine. In the direction of the angle cos, another one sine. Then about the initial point you can rotate that vector into two perpendicular directions. One of them 5 cos 53, another one 5 sin 53. Right. Now I am going to take another example. Now you are given 10 newtons to resolve. 10 newtons, and you are given angle here 30 degrees. Now you should know how to find components of them. You know horizontal component cos in the direction of the angle cos, another one sine. Then I can take this into cos 30 horizontal one, this into sin 30 vertical one. Then I can write horizontal component here 10 cos 30. Vertical component I can write, I told you, opposite side sine, 10 sin 30, 10 sin 30. And we know sin 30 is half. Sin 30 half means, 10 over 2, it's 5. Then vertical component 5 newtons. But it's a horizontal component. Cos 30, root 3 over 2. You have to memorize those values, right? Cos 30, sin 30, tan 30, cos 60, sin 60, tan 60. You should know these values. Then cos 30 square root 3 over 2. Then 10 into square root 3 over 2, it's 5 root 3. Actually, you can see we found this kind of, we found resultant of this kind of two vectors. One of them was 5, one of them was 5 root 3. And we found resultant. We saw that 10 newtons. Same way, in the other way round, we resolve that. Then you can see same answers are coming again. Then you should know how to find resultant, how to find components. How to find resultant? This squared root, Pythagoras principle. How to find components? Then in the angle, with the angle 10 cos 30, in the direction of the angle cos, another one sine. And it's very, very important thing, arrowhead direction. Arrowhead direction. I'm going to do many examples. Now you can understand this one. 10 cos 30 and 10 sin 30 we found. Now I'm going to do another example, right, with many directions. With many directions. First one we are given 10 newtons, angle 30. You can resolve this 10 cos 30, 10 sin 30. Horizontal component 10 cos 30, 10 sin 30. And you can see sin 30 half, therefore 5 newtons. Cos 30 root 3 over 2, therefore 5 root 3. Then in the direction of the angle cos, another one sin. Sometimes, right, angle can be given in the other side. You are given not 30, you are given 60. Now how do you resolve? Again same principle, I told you in the direction of the angle cos, 10 cos 60 is the vertical one, 10 cos 60. Anyway, I am going to write that here, 10 cos 60. 10 cos 60, another one 10 sin 60, horizontal component. Now you will see same answer because cos 60 half, half means again 5. Sin 60 root 3 over 2, same answer. Therefore, whatever the angle you consider, no problem. Whatever the angle you want to consider, no problem. In the direction of the angle cos, another one sin. Right? Therefore, always it doesn't need to be 30. It can be 60 also. Same answer is coming. Now, I am going to find resultant two components of another vector. It is given this way, 30 newtons. 30 newtons, you are given this angle 60. Now, how do you take components of them? Same principle, it doesn't change. Then arrowhead this way, you can see downwards. I told you it should be rotated above the initial point. Then 30 cos 30, cos 60, 30 sin 60. 30, this angle, we are resolved this way in the direction of the angle, always cos. Another one, sin. Therefore, in the direction of the angle, we can resolve this cosine 60. Then horizontal component I can write here. It's very, very important. Direction of the arrowhead. You have to rotate it about the initial point, right? About initial point, you are rotating that, right? This way and this way. Arrowhead should be downwards and leftward. Then 30 cos 60. This is a horizontal component. How much the vertical component? It's 30 cos 60 this way, 30 sin 60 downwards. Arrowhead, very, very important. Direction of the arrowhead, very, very important, right? Then 30 in the direction of the angle cos, another one sin. 30 sin 60. Cos 60 half, cos 60 half, then 15 newtons, right? Sin 60 root 3 over 2, root 3 over 2, then answer 15 root 3, right? 15 root 3. These are the components. That means, if you want to find resultant of these two, you will see again this vector. If you find resultant of these two perpendicular vectors, you will see this one again. Therefore, learn that in both directions, finding resultant and resolving. Find the resultant, resolve that. One more example. Now consider you are given vector this way, 50 newtons, and you are given this angle 30. Now you can see arrowhead this way. Then you rotate it about the initial point. Downwards, because arrowhead this way, no? Downwards, another one this way. Then 20, 50 in the direction of the angle cos, another one sine. Very easy. Then downwards you can mark one vector 50 cos 30. In the direction of the angle I told you always cos, another one sine. Then this angle we have 50 sine 30. Then how define resultant of them, right? How define each vector? Sine 30 half, 15 to half, you know, 25. 15 to cos 30, you know, root 3 over 2. 50 should be multiplied by root 3 over 2. Then 50 divided by 2, 25, 25 root 3. Then you must be careful when you are drawing arrowheads. In the direction of the arrowhead, right, according to that, you have to take horizontal component, vertical component. If it is this way, horizontal component, vertical component, right? If it is this way, right, horizontal component this way, vertical component this way. With the arrowhead, you have to learn that. It's very, very important principle when you are doing big questions, right? You will see in small parts of that question, you need to find these vector components. Now, I am going to find I am going to do another example to find the resultant with vector resolving principle. Next example. Now, consider we are given this kind of three vectors to find the resultant, right? To find the resultant, I told you normally we are finding first vertical resultant. After that we are finding horizontal resultant, right? Then finally we need only two vectors which are perpendicular to each other. Then how to find that? Then you know these two are already in the horizontal direction and vertical direction, only the problem this one. Then you know how to solve that, right? You can resolve this vector in the horizontal and vertical direction. How do you resolve? We know, I told you, in the horizontal direction, arrowhead this way, cos 30. This one sin 30. Then you can resolve this. Then instead of this 20 Newton's vector, right, instead of this one, right, you can't keep it here again after resolving because it was resolved, after that it's not there. I am going to take components of this vector. What are the components? In the direction of the angle, I told you cos. Then this component I can write 20 cos 30. Horizontal component. Vertical component 20 sin 30. Vertical component you can draw here 20 cos 30, next one 20 sin 30. We know sin 30 is half. Sin 30 half means here value 10 newtons. And you know cos 30 root 3 over 2. Then 10 root 3. 10 root 3 this direction. Now you can find horizontal resultant first. How much? 40 into root 3, 10 into root 3. Difference of them you know? Difference of them you know? 30 into root 3. Difference of them. Then you know horizontal resultant, difference of them 30 root 3. It's very simple. Vertical resultant you can see downwards 40, upwards 10, difference of them downwards 30. Then you have downwards 30. Then here both principles are together. How to resolve and how to find resultant. Then we can find resultant of them. Here apply Pythagoras principle to find the resultant. It is equal to 30 root 3 squared, 30 squared, square root of whole thing. 30 root 3 squared, 30 squared, square root of whole thing. 30 squared 900, 900 into 3 2700, plus 900 3600, square root 60 newtons, and you need angle also. You know, when you are finding resultant of a vector, you need direction also. Tan theta is equal to what? Here opposite over adjacent. Opposite means this one. 30 over 30 root 3. 30 over 30 root 3. Then you can see 1 over root 3. Then theta is equal to 30 degrees. Next lesson we can do vector parallelogram principle and vector polygon principle. And you can see these videos in NIE YouTube channel, right? All the videos are there in vectors and second part of vector also. In the second part of the vectors, we can do vector polygon principle and parallelogram principle. Then have a nice day. Thank you very much.